In this video, I'm going to explain how we can derive the different forces involved in machining of single point cutting tool. The main aim of this session is to familiarize the students with the different cutting force equations and main instructional objectives is enumerate different cutting forces involved in single point cutting tool and derive different cutting forces. What are the learning outcomes after completion of this session is the students able to understand the different cutting forces and clear about how to derive the main component of cutting forces, especially by using merchant circle diagram. Now, you will look at this. In earlier video, I explained the merchant circle diagram, how you can construct the merchant circle diagram, what are the different force components are involved in a single point cutting tool. Once again, just brush up what are the different force components are there. The FC is equal to cutting force, that is the main cutting force acting on the workpiece by the tool. And Ft is the thrust force acting vertically downward direction on the workpiece, that is indicates the Ft. And Fs is the shear force, it is the acting on the shear plane. So the shear force is acting Fs. Fn, normal to the shear force. Ff, frictional force, that is the between the chip and tool surface, the frictional force mainly acting. And the normal force, which is normal to the frictional force or perpendicular to the frictional force. And what are the different angles? That is, the alpha is the rake angle that we can measure from the vertical line to the tool surface, and beta is the shear angle from the horizontal line to the shear plane, that is the shear angle, and gamma is the friction angle, so which is the inclination between the resultant and normal, so that is the friction angle. Okay, so these are the main force components. Now we are going to derive equations to determine these forces: cutting force, thrust force, shear force, normal to shear force, frictional force, normal force, with the help of the different angles, that is the rake angle, shear angle, and friction angle. Now, today first just mark the salient points on the merchant circle, that is the A, B, C, D, E. Now, let us find out what is the length of the shear plane AB, that is the H. And here we can mark the T1. The T1 is the thickness of the chip, that is uncut chip thickness, and T2 is the cut chip thickness. These two are different. It's not the same. The coefficient of friction is denoted as a mu, and this coefficient of friction, we know it is equal to the ratio of the frictional force to the normal force. Let us, this is the mark as a equation 1. And from this we can also write the mu is equal to tan gamma. Mu is equal to tan gamma. Here the tan gamma is equal to Ff by n. So you can replace Ff by n by tan gamma. So from the equation 1 and 2, the frictional force we can find out n into tan gamma. And the chip thickness ratio is denoted as T1 by T2. That is the uncut chip thickness to the cut chip thickness. And this angle BAD is just marked as the theta, that is equal to summation of the shear angle beta plus gamma minus alpha. Now let us rewrite the portion of the tool, and you can show the thickness of the uncut chip thickness and cut chip thickness, that is the T1 and T2. And from this trigonometry, you can easy to write down what is the thickness of uncut chip thickness, the T1, that is equal to, in terms of the shear angle, that is the H sin beta. So we can obtain T1 is equal to H sin beta, and T2 is equal to H into cos beta minus alpha. Beta is the shear angle, alpha is the rake angle. So here T1 and T2 are thickness of chip before and after cutting. So from the equation 3, you can rewrite R is equal to T1 by T2, that is equal to H sin beta by H into cos beta minus alpha. Now H gets cancelled and the R is equal to sin beta by cos beta minus alpha. Let us mark this is the equation 4. So from this equation 4, you can simplify, you can expand cos beta minus alpha, that is cos A minus B, that is the cos A cos B plus sin A sin B. Expand that formula here, then you can simplify, then you can obtain here, you can see that so R cos beta cos alpha divided by sin beta plus R sin beta sin alpha by sin beta is equal to 1. So just cross multiplied the above equation, then rewrite this equation, it's obtained like this. And from this R cos alpha by this sin beta by cos beta is tan beta, that you can written here, that is equal to, and the remaining term taken to right side, that 1 minus R sin beta cancelled, R into sin alpha. Let me take highlight. So that is here for simplifying this equation. So now from this tan beta, the tan beta is equal to, take this term to the right side. Okay, so that is the R cos alpha by 1 minus R sin alpha. This is marked as the equation 5. This is marked as a equation 5. That is I want to take pen. This is equation 5. You can. Okay, now let us rewrite instead of the merchant circle what we have shown here. Now just I want to mark the different points and different cutting forces for the further derivation of the equations. Now let us see that. First mark the cutting force, that is Fc. You can represent that you can represent, draw the line AB. It indicates the cutting force Fc. Then draw the line which indicates a thrust force, that BC is acting as a thrust force. Now the cutting force and thrust force are perpendicular to each other. Now we can represent the shear force. From A you can draw the line and represent this D, AD, that indicates the shear force, and from D draw the perpendicular line that indicates the normal to the shear force. Now the inclination between the normal to the shear force and shear force is again perpendicular. Now again we have to draw the frictional force from point A, and from point C draw the line perpendicular to FF, that indicates the normal force. Okay. Now you can see that the angle of the frictional force from the vertical is equal to the rake angle, that we can mark as a alpha, and the shear angle. So the shear force from the cutting force is indicate the shear angle, and here this angle BCD is also equal to beta. BCD is also equal to beta. How this beta is obtained? We know what is this angle. This angle is here it is 90 degrees and this beta. Okay, total all three angles must be 180 degrees. So 180 minus 90 minus beta. Okay, so that is the 90 minus beta. So this is equal to 90 minus beta. Then so this is also equal to 90 minus beta. And if once it is 90 minus beta and this 90, and this angle must be equal to beta. Okay. So now next, this alpha, how it is alpha is came, let us, if we consider this angle alpha and this is 90 degrees, and what is this angle? This angle is equal to 90 minus alpha, and this 90 minus alpha and this 90, and this must be equal to alpha, so that this entire angle must be equal to 180 degrees. Now this angle is alpha. So now we can draw the resultant line, join A and C. This R is the resultant of all these set of forces. The R is the resultant of cutting force and thrust force, and also the same R is the resultant of shear force and normal to the shear force, and the same R is the resultant of frictional force and normal force. And the angle between the normal force and result force is that is the friction angle, that is gamma. Here we are discussing about three angles. One is the rake angle, alpha, beta is the shear angle, gamma is the friction angle. So now we need to find out the different cutting forces. Okay, now I need to find out the cutting force Fc. So how this Fc is obtained from this geometry? Okay, from this geometry. So this from the point A to B is indicates the cutting force Fc. Okay, and this cutting force Fc is also obtained. Now if we consider these forces, okay. Now let us we can mark A, B, C, D, E. Now let us mark this is the point E. Mark this is the point E. Okay, and this is the point F. Now let us consider this is the point F. Now from the triangle, the CED, this is the one triangle, and DF is another triangle. From this triangle, we can find out the side ED. Okay. Now this is the angle beta, and this is the hypotenuse FN, and this must be equal to the Fn into sine beta. So that is here written Fn into sine beta plus this df. Df is what is this angle? This angle is also equal to the shear angle. Okay. So then this if you angle this angle is beta, then this adjacent side must be the fs into cos beta. That is written here fs into cos beta. Now name this equation is 6. Okay. Now from this the cutting force Fc is equal to Fn into sine beta plus Fs into cos beta. Now we can find out the Ft also. We can find out this Ft, how this Ft is obtained once if we know the CE length, and we can subtract from CE length EB length. Okay, then you can obtain the tangential force. Okay, now again you can consider these sides. Okay, now what is the side CE? What CE is this Fn into this is adjacent side. So that is the Fn into cos beta minus. So this BE must be also equal to AF, and this AF is opposite to this triangle beta. So that is the Fs into sine beta. Okay, now you can subtract this Fs sine beta from this, then you can obtain this component of force, that is the thrust force. Okay, now thrust force is obtained using this equation. Let us name this equation is 7. Okay, so now from these two triangles, that is the CED and DFA, from these two triangles we are obtaining these two equations, and we are obtaining the cutting force and thrust force. Okay, now further can simplify these equations, that is multiply equation 6 with sine beta plus multiply equation 7 with cos beta, then you can obtain this Fc sine beta plus Ft cos beta, that is equal to Fn. So this Fn sine square beta plus Fn cos square beta. So Fn take common, sin square beta plus cos square beta, that is equal to 1. And here these two components are gets cancelled. These two components are both are equal, because here Fs cos beta sin beta and here Fs sin beta cos beta, both are equal, so it's cancelled. So finally you can obtain this normal force component. Okay. So now you can another you can do that. So that is multiply equation 6 with cos beta minus multiply equation 7 with sin beta. Then you can obtain the another equation. So that is the shear force. Okay. Okay. Now you can see that Fc into cos beta minus Ft into sin beta, that is equal to Fs. That means here these two components are gets cancelled, and these components will be the Fs cos square beta minus of minus plus Fs sin square beta. Here sin square beta plus cos square beta is equal to 1. This is the Fs, and these two components are same. It gets cancelled. Okay, this is the shear force. So you can obtain the shear force from this. So far we calculated the cutting force, thrust force, shear force, and normal to the shear force. These four components we are determining. Okay. Next, we'll see that we want to find out the frictional force and normal force. So for these two forces, again similar to this earlier, now we can consider these two triangles. Okay, now let us you can use this triangle. Okay, so this is the triangle C. Now we can just mark this point is, let us, this point is G. Okay, and this point is H, and this point is high. Okay, now we can mark these points. Now let us consider this triangle, that is a CGH. From this triangle, and this is the angle alpha, you can find out this side. Okay, and again from this triangle you can find out this entire length HI, that is equal to the cutting force FC. Okay. Now let us consider Fc is equal to, here from this triangle, n cos alpha plus ff sin alpha, that is the equation 10. And ft again consider this side. Okay, ft is equal to ft cos alpha, so that is ff, the frictional force, into cos alpha this side. Okay, that is ai minus, and this one, so that is equal to n into sin alpha. Okay, now this is the equation 11. Okay, so now here we derive these two equations. From these two equations, we need to find out the frictional force and normal force. Similar to the earlier, now for the simplification, multiply equation 10 with sin alpha plus multiply equation 11 with cos alpha, then you can obtain the frictional force. Then you can obtain the frictional force. Now you can see that the frictional force FF is obtained. The frictional force FF is obtained. That is the equation marked as a 12. So again you can multiply equation 10 with cos alpha minus multiply equation 11 with sin alpha. Then you can obtain the normal force. Okay. Now you can see that all the forces are derived. Okay, that is what are the forces? Cutting force Fc, thrust force Ft, shear force Fs, normal to shear force Fn, frictional force Ff, normal to the frictional force, and all forces are derived through these equations. And also you can find out the resultant force of these components, that R is equal to square root of n square plus ff square, or fs square plus fn square, or fc square plus ft square. Anything you can obtain the same resultant value. So this session, I hope everyone understand how we can derive the different components of cutting forces which are involved in single point cutting, using single point machining of the component. Thank you.